Hey everybody, welcome in that new video of the Golaem engine within Golaem 8. So this is like the beta version Quickstart to help you getting started with that new feature that we provided into Golaem 8, which is called the Golaem engine. The Golaem engine offers you the ability to export your simulations as a digital asset and play that simulation into other context. So that means that you get interactive simulation outside of Maya. So the first targeted platforms we're going to show into that video is going to be Unreal. But Golaem 8 also come with an SDK if you want to integrate that engine into your own DCC, or maybe later we're going to provide more integrations as well. So that means that you create your simulation within Maya, you create your assets, you create your behavior graph, like what I did here. And when you're happy with that, you can just export, do settings, serialize the simulation, and bring it into another DCC to execute it and maybe change some attributes as well. So I made a pretty simple simulation where I have 400 characters something. As soon as they enter the green zone, they'll start running. As soon as they enter the red zone, they just turn into physicalized, so they're just a full. And all my character gathers to that point here at the bottom of the scene and try to reach it. So here what I want to do is bring that exact same simulation within Unreal and maybe have different attributes within Unreal. Maybe I want to change the terrain, I want to change my zones there. So to do this, I will have to expose some of the attributes. So the graph here is kind of going to be fixed, but all the attributes of the graph, all the different attributes of the behaviors is something we can actually change. If we want to change those attributes, we need to go into the crowd manager, open the Golaem engine attribute panel here, and we end up with a string attribute called Golaem public attributes. There's a helper button here, which when you open it, lists all the scene nodes, with every single attribute which you can override into your Golaem engine. And you just have a list and also the type of all the different attributes here. So maybe let's say within Unreal we want to override the geometry of the terrain, so I can check the terrain node, go into the geometry attribute, which is a mesh array, so it's going to be a list of mesh, and I'm going to say that I want to publicize, so expose that attribute here. I may also want to change my polygon zone triggers I'm having here into the background, so I'm going to type writing here polygon or zones, or maybe I can search for triggers, and now I can see that within the run trigger node there's something called the polygon zones, which is also a mesh array, so let's select this, and the full trigger node is also a mesh array, so select this. I also may want to change the target, so I'm going to type goto, which is the name of my behavior, into my behavior graph, and within the goto behavior here I want to go into the in target positions, which is a vector free array, so you can, here I just specify one positions of target, but obviously you can provide multiple, so this is why it's an array, so I'm going to expose this. Okay, I'm kind of good with all those attributes, but you've got all the attributes here of your scene that you can override anytime. If I apply this, you can see that now within that string attributes, I'm having the name of my nodes and the name of my attribute, which gets stored into the scene. So let's save the scene from here. When you're running Golaem 8, you get a new button here, which is the engine exporter, which allows you to serialize your simulation, so all your nodes and your public attributes, and export this into a digital asset. So I'm gonna export this here into a Golaem 8 engine, save it here, and maybe we can take a look quickly at what we just saved. So what we just saved is a GDA file. So GDA stands for Golaem Digital Assets. It's a JSON file which contains all your nodes, your node connections, value of the different attributes as well. And it's a self-contained directory, so it has all the resources which are required for that digital asset to be run into another context. So if I open the resource, I can get my character. Right now I'm just using one, which is the Soldier Fortress. I'll get also some geometries, because we need to know how looks like those zones and terrains we need to adapt on. We need to be able to bring this into another DCC and be independent from Maya. So we exported this into a Golem terrain geometry, which is more or less just some mesh geometry. It's not only to store terrain, it's to store meshes. And finally, there are all the motions I'm using for that character in that scene. So it's a self-contained. You may have noticed that also I exported an FBX, so I manually exported that FBX. Within the beta, right now the GTG files cannot be loaded and seen within other packages like Unreal. So this is why I exported this as an FBX to be able to bring this within Unreal. And now I'm good. Which means that if I go into Unreal, here I already proceeded and loaded my FBX file, so I've got my terrain and my zone, and I'm good to start. Also, just as a preset here, I also loaded my Fortress Soldier, mostly because I want to be able to drive the shaders and see the geometry within Unreal. So what I did is I imported the GCHA, so Golem character file that I could figure here, and it imported for me all the meshes, the skeletal mesh, the shaders, and I set the shaders manually here for that use case. But I pre-imported my character in the scene, which is required if we want to Golem to figure that character. So let's say we need to load that digital asset within Maya. What I can do now is create a new node called the Golem simulation node. So those are the nodes which are allowing you to replay caches. So once you exported a cache, you can replay that cache. This is something we had with Golem 7 and before. Golem simulation is something which is brand new in Golem 8. It allows you to have an interactive simulation. So before, everything was baked and you couldn't change anything within the sim. Now you can change anything and all the attributes that you exposed. So that Golem simulation node, let's put it into the scene origin so it's aligned with my terrain. And if we take a look amongst the various attributes, you can see there's something called GDA file, so Golem digital asset file. And it's apparently a path I can load a file into. I can change the draw entity %, I can see the current time, my license, and all the casual stuff. So let's go ahead and load that battle scene simulation. And as soon as I do that, you can see that GDA properties array just move bigger and some attributes appear in it. And those attributes are actually the public attribute that we decide to expose. So within Unreal now, we've got those entry points that we can change either manually here or either using the blueprints if you want to have something more interactive within Unreal. And you can override those if you want. And as soon as we got that node, if we press play, as we expect, we should get 400 characters being loaded into Unreal and executing the exact same thing. When my characters enter the red zone, they fall. When they enter the green zone, they just move, and they just converging to that point, imaginary point, which is around here there. So far so good. What if I change that zone here? If I decide to change, the lighting is baked, so this is why the shadows are not moving. If I change that zone here and I launch the simulation, my characters will not be influenced by this. Within the digital asset file, we've been storing, the mesh we want to use for that trigger. So if we change it here, that's just a viewport information. This is not something which is influencing the simulation. If we want to influence the simulation, this is where the public attribute were just exposed go into play. So we want to change the full trigger node here. So what we can do is double click on that mesh property that we have, and we can override that property, and you can see that as soon as we override it, that undim that array here. So it's a 2 array element because within Maya we provided 2 meshes for the trigger to react, but obviously we can remove one if we want, or we can add more if we want to extend that capacity. And what I'm going to do is just specify that the zones I want to use now are the meshes which have been defined within Maya. So now if I move, let's move that zone and put it maybe here. and put that zone maybe there and play. And now I'll get my characters. As soon as they go here, they start running, and as soon as they enter the red zone as we expected, now they start falling and still converging with their targets in the background. So I'll make a second video about how you can change this dynamically within the blueprint, so you can design something more advanced using the Unreal blueprint system, which is allowing you to program some behaviors for your objects, or maybe declare and triggers some behaviors for your agents. But just to end up that video, I would like maybe to change the target. So the target is of a different type. As I said before, it's a vector-free data. The unit is going to be the unit within Unreal, so probably within Maya it was 24.72. As Unreal is in centimeters by default, now we've got centimeters expression, so we've got multiplied by 10 values, and that's the same almost everywhere within the UI. We can add multiple targets if we want to. Let's say, well, we're going to say, okay, there is going to be one at 3,000 and 3,000 on the y-axis, which is going to be on their right side of the entities. And maybe I want to bring some characters back and just define another target. And now we'll have two positions. And if we play that simulation here, we would expect to have some characters moving here on the right, front and right, and the other half which are trying to make their way to the back of the scene here. So we kind of scattered the crowds into two different zones here. So which means that we have complete control on what's going on within the simulation, and we can change whatever attribute which in it. So I hope that makes sense, and see you in the next video regarding how to set those attributes with the blueprint.